everybody, welcome back to, I believe, video number 7 now for the Solidworks RC airplane design series. So the last video we left off with the canopy bulge being lofted, and I told you that I had to kind of figure out how I wanted to go about doing the very front of the canopy, or in this case the windscreen area. So after a couple of hours of fussing around with that, I kind of finally figured it out. So what I decided to do is here at, let me find it, station 51.25. That is the very far front edge of our new of our canopy point. So what I did is I made a plane at 51.5 inches, and I called it Canopy Station 51.5. And then what I decided to do is using our top outline, and then our 3D curved splined outline, I developed this sketch here that is Canopy 51.5. And I'll move the screen around here, and what you'll see is it's basically just an L shape with an arch between the two. And then of the L shape, we have this point here is coincident with a 3D sketch arc, and then this point here is coincident with our top outline. And then all I did is I just redid the loft to where I included this profile, this 51.5 sketch profile. And then we ended up with our entire loft here of the canopy bulge. And that gave us the vast majority of our windscreen. And by the vast majority of the windscreen, I mean all but this one little bitty area right here. So in order to do that little area, we have to use what is called a boundary boss or base. And boundaries, bosses, and bases are one of those things that I absolutely hate to use because they're frustrating. You sit there and you constantly work at it over and over and over again until you figure it out. As you see here, I've got one there, and it's not perfect, but it's close enough. Like I said, there's going to be a windscreen here. There's a canopy flange or a windscreen flange for the framing and everything there, and it's such a small. We're only talking about a quarter of an inch on the full size airplane. Really, you don't even have to bother with this boundary, because by the time you make this, you scale it down to a quarter scale. Your quarter of an inch becomes a 16th, and an eighth of a scale it becomes, I believe, like a 1/64th or 1/32. It becomes extremely minute to where you'll never even know it. So because of that, I'm not going to go over the boundary things right now because, like I said, they're a pain to deal with. I don't like to use them unless I absolutely have to. And I did this just to see if I could make it happen, and it worked, but it didn't work all that great. So once we have all of that done, what I then did is I just used our mirror function. I chose our mirror plane, which would be the flat face of our fuselage. And then I selected the fuselage, merged solids, the green check arrow, and here we go. Now we have our complete fuselage. If we come back to our evaluate, see the curvature here along the bulge, just nice and consistent. The fuselage we know is pretty dang good just based on looking at it before. Here from a frontal view, you can see again the canopy looks really, really consistent. And the top view, again, is pretty dang consistent. If we do the zebra stripe method, again, you can see everything looks really, really good. Back to the frontal view, and again, the side view. So that basically gives us our basic fuselage structure. After that, I did this fuselage canopy combine. What this feature does is if you have two options that just aren't merging to the solids, you can use this feature. In this case, this was an extrusion. So what I did is this little area here of this boundary, it had what they call zero thickness geometry, which means if two parts are completely butted flushed with each other, or there's a very, very, very minute gap, like a 0.0 to the who knows power, it won't combine them. So this case, what I did is I just did an extrusion off the back of this part into this piece to allow it to combine into a single solid. And then this cockpit rail sketch, you don't need to worry about that. The ventral side fin sketch. This is a sketch that I used from my documentation packet to get all of the dimensions. As you'll see here, there's a lot of dimensions associated with this. A few things I did change about this that the documentation didn't have. This point right here, this root line, this is not technically there on a documentation. It only has this dashed center line here shown on the documentation. And since we need the ventral fin here to extend into the fuselage, I just extended the leading edge and the trailing edge outline and did this line here for our plane location. Same thing here at the base or at the tip of the ventral fin. I put another line here in the correct location based on the documentation for that. And then using that sketch, I came up with the fin root sketch plane here, and then the fin station 67.5, which is the very tip of the ventral fin. Then based off that and the documentation packet I have, I did the station curves for both the 62, which is this line here, and then another one here, which is this 28.6 to 39.22 curve, which is this canted line here. That's why it has two different station locations. Now, as you can see, again, XYZ curves that you use using this curve through XYZ points, it's always on the front plane. Unfortunately, I haven't figured out a way of modifying that just yet to where it's not on there, but that's just how it is. One thing I did change, the documentation says there is a 50 thousandths thickness trailing edge, a radius. Since this is going to be scaled down to an 1/8 and a quarter scale size, what I did is instead of making this 18.18 here, where at the very tip would be 0, I went ahead and added that 50 thousandths. So by the time you do 50 thousandths on both sides, it's a 1/10 of an inch, so just under 1/8 or about 3 millimeters. And that would just make it a little bit easier when it comes time to draw the smaller scale fuselage, or I'm sorry, the wings and the ventral fin parts and the structure. So those curves done. What I then did is I did this sketch here using the convert entities. I sketched on the front plane, converted the entities. This curve was actually up here. I just used the tools, sketch tools, and then the move feature. And I selected what I wanted. And then I just did the X, Y, and you can see you can move those items wherever you need them to be. So once I had that, since I just had the top curve, I used the mirror entities. I put a center line here. And then at the very trailing edge, you can see I just put a vertical line. Again, the documentation says it's a 50 thousandths radius. But since this is a CAD model and it's going to be scaled down, I did not do the radius. I just did a squared off trailing edge. So with those both created into a symmetrical airfoil, what you can then do is just click and drag across and then edit and then copy it. And then when you go down to your ventral fin root plane, you can sketch there, you can paste that profile that you had, and then using your tools, sketch tools, your rotate, move, and scale, and doing some math, you can make it fit both the root and the tip airfoil, because this is a symmetrical airfoil. The tip is just a smaller scaled version of the root. So if you do the math, the size you want divided by the size you have, or vice versa, you can figure out if you need to make it larger, if you need to make it smaller. So once I had both of those sketches done, I'll show you the sketches here. On the ventral fin, we end up with a fish missing a couple of fins. So here we have our ventral fin root airfoil. Here's the tip airfoil. Then what I did is I did a 3D sketch, and then just using the line feature along the center line at the center point of the leading edge, and then again at the trailing edge, I made a duplicate outline of the ventral fin. Then with all three of those items done, you can do a lofted boss or base here. For your profiles, you have your root and your tip airfoils. And then your guide curves, you have your leading edge 3D sketch and your trailing edge 3D sketch. You want to merge all the tangent faces. You want it to show your preview. You want it to merge your result. For your feature scope, you want to unselect auto select, and you want to select just your fuselage. So you have all that done. Click the green check arrow. And there you have your, oops, wrong one. And there you have your ventral fin. Now the ventral fin is ready for any fillets you would like to add. I'm still debating if I'm going to add the fillets or not, because honestly, it's an RC model. Your fillets are going to change, and probably no one's going to build the fillets identical to the correct radius. If this was going to be a fiberglass fuselage, your fillets would be very nice to have them there. And since I do plan on doing a fiberglass one of some scale, I will likely try to get the fillets in there. Right now, the filleting tool, which is right here, is causing me some grief with this one, so I'll have to kind of fiddle around with that one a little bit more. And then here you see we have our ventral fin tip cut. This is just a sketch that I used to develop the based off the documentation. You can see, trim that one because I forgot to do that. It's just a radius at the trailing edge, the leading edge, and then the leading and the trailing edges actually stay there. I just made this drawing. For the leading edge, I used a convert entities tool to draw up that line. Same for the trailing edge and same for this tip there. The curvatures, I just drew a circle about like that, and then I used the tangent relations for this line, that line, and then again for the trailing edge and the tip. Then I put in the radiuses for it, got rid of what I didn't need using the trim tool, just like that. You can see it leaves a nice little gray line. Anything that gray line goes over gets cut away. Once all that was done, I did the extrude cut, which I will show you just a second. Extrude cut pops up this. And for this one, since it was drawn on the right plane, you want it to be through all in both directions. That way it cuts both the left side and the right side. And then you end up with that profile along the trailing edge tip and the leading edge tip of the ventral fin. Then after that, it was beginning to look at the top outline of the ventral fin on the top, or in this case, the vertical fin. This is just a little sketch that I did based off of the documentation that I have for the very tip of the original version 1 vertical stab, which if you even want to call it a vertical stab. But basically, it's just a sketch using the dimensions that I have based off of my documentation. And then I extrude bossed it. I did the features extrude boss base. And basically what I did here is I just did a mid-plane. And then I only did it a 1/16 of an inch. It doesn't have to be very thick because we're going to model the version 2, which had a full-size vertical stab on the top. And all of this is basically going to get covered up more or less. And then you see here we've got just this little bit right here sticking out above. So I just did another little adjustment to cut that piece off to give it that nice little curve across the top. After that, it was just basically repeating what I just showed you for the ventral fin for the vertical stab on the top of the fuselage. I don't have any official data from Northrop showing the exact dimensions and everything for this particular part because this was a afterthought scab patch, scab edition, however you want to look at it. But luckily, someone back in the 80s, I believe, did a very detailed and very thorough drawing and measurements of the vertical stabilizer that is attached to the sole remaining example of this airplane. And based off that drawing, I was able to get enough data out of it to basically come up with the trailing edge is collinear with the original trailing edge of the top vertical fin, whatever the thing is. We knew based off of a certain station location, down 7 inches, he had a line, and then back from along that line, 32 inches, he has another line, which was, I'm guessing, panel lines across the part. And this came up to this location here, where the leading edge was, to give you 27 inches. And then the very tip of it was 17 inches. So we are able to basically come up with a vertical stabilizer outline that gives us the shape of it. Again, here I've got our center lines for our plane locations, which I also did using the geometry. Hasn't changed as far as how I did it. For any of the fuselage stuff, it's just all repeating. That's why I'm not really going in depth as I'm doing this, because there's plenty more instances when we're going to be doing the wings here pretty soon. The wings are fairly simple, but this airplane's a little complex because of how it is. So the next thing was I used exact same airfoils that we use in the ventral fin for the vertical fin. The main reason, there's no data that I can find that says that, hey, this isn't correct or this is correct. So based off that, I'm assuming that for simplicity's sakes, they probably just copied the ventral fin and flipped it over and put it on the top. So again, I copied and pasted the the ventral fin 28.6 39.22 curve to the vertical stab root plane. I moved it around using that sketch tools, move, rotate, scale, and all that stuff. And I got it to fit the root, fit the stab outline here. You can see the leading edge and the trailing edges match. I did the same thing with the tip. And then I also 3D sketched out the leading edge and the trailing edge. And then I did a loft, again, using the root and the tip airfoils for our profiles, and then the 3D sketch leading edge and trailing edge lines as an open group for our guide curves. Again, we merged the results. We unselected auto select, and then we just chose the fuselage part in itself, the green check mark, and ta-da, we have a vertical stabilizer that is probably more accurate than what they ended up scabbing onto the second prototype, because the second prototype has a pretty straight line about here and then here where it would have come together, and I think they literally just hammered metal in place to get it to fit. So with that done, we then do our cut extrude up here to shape the leading edge and the trailing edge of the tip. And with that, we have a XP56 fuselage, cockpit, and ventral / vertical stabilizers. And that pretty much brings it up to the point that I am at now. I haven't done anything additional at this point. I'm going to probably work on coming up with the fillets along the cockpit bulge, and then again around the ventral fin and up here around the vertical stabilizer. But other than that, the fuselage itself for the 3D model is basically done. So for video 6 or 7 or whatever this is, I gotta start writing down which video I'm on so I don't sound like I'm completely confused, even though most of the time I am. But anyway, for this video, that pretty much brings you up to date on what has been completed as of today, September the 9th. So I'm going on a road trip this weekend, starting tomorrow on Friday, to the Air Force Museum to see a couple of buddies, probably take a lot of pictures, hopefully find some good reference data on a couple of projects, and then I'm coming home, and who knows what will happen after that. Probably start doing some more XP56 work. I might even do a little bit of work on the XP56 this evening after dinner. So anyway, if y'all have any questions, please feel free to ask all you need. I know it's a lot of information. It's like drinking through a fire hose. Again, I've been working on Solidworks, self-teaching myself this stuff for close to, if not more than 10 years now. So I understand that it's a lot to take in. But I'll do my best to answer it as best as I can. So again, I hope you all have a great weekend. Thanks for tuning in, and we'll see you next time.